Hello everyone. I am uploading my task 6 given by the Sparks Foundation, and the task is all about creating the decision tree classifier and visualize it graphically. And the purpose of the task is if we feed any data set to the classifier, it would be able to predict the right class accordingly. For this, I am using tool Python, and the software is Jupyter Notebook, and I am importing the necessary libraries for this, and I am loading the data set for this. And as usual, I am importing NumPy as NP, importing pandas, importing matplot, libplot, pyplot for the visualization, and most importantly, I am importing from sklearn.tree import decision tree classifier, that is the algorithm of the model. And now we are reading the data and we are storing it in the ld underscore df, and we are checking the data as usual. Ld underscore df dot head is the checking of the data set, and we can see the data is loaded successfully, and now we can see the columns of the data also. And here in the data set we have the IT column, which is of no use for us. So we are dropping the unwanted variables here. So we are dropping the IT column from the data cell. And here we are again checking the head of the data so that we can check whether this IT column is dropped from the data set or not. So this is dropped successfully, and now we will check the shape of the data. This is 150 rows and 5 columns. Here we can manually also see that there is 5 columns, and here we have checked it from the code dot shape also. And now we will check the info of the data, whether the columns are integer type or the object type. So here we can see that the all the values are non-null and the data is clean, because in decision tree classifier it is very essential that we have all the variables in the integer type, not the object type. If we have the object type, we should convert it into the integer integer data type. So here we are again checking for the null values. There is no null value in the data set, we can see. So this is also very good on our part for the 88th section. And now we will see the duplicates in the data self. There are 3 duplicates only. So this is negligible because data self itself is very small. So I will leave it like this only. And now we will see a description of the data. So this is the description of the data, and I have transposed it for the ease of the site, because this is easy to read the description of the data. So here are the mean standard deviation, 25 percentile, 58 percentile, and 75th percentile, and maximum of this. So it is easy to understand if we transpose it. And now we will see the correlation in the data set, and here we have stored it in the CORR core variable, the correlation of the data set. And here we can see the correlation, and manually also we can see that variables are correlated, or they are positively correlated or negatively correlated. So here we can see that sepal width is negatively correlated with sepal length, and petal length is positively correlated with sepal length. So here also we can see manually, also we can see by the number also, we can see that whether they are negatively correlated with the other variable or the positively correlated with the other variable. So here we can see by the picture itself, also by the heat map. So here sns.heatmap and we will give the correlation, and a not is equal to 2 means we want the printed one heat map, and here we are giving the color, and darker the color is, the more the correlation is. So we can easily see what all variables are correlated, or what all which all variables are negative correlated. And now we can see also by the pair plot also. Here we have given the hue is equal to species. The dependent variables color we have given to the pair plot, and this is we are setting the color of the uh, picture only to to look better. So here, because this is a pair plot, so this is of the whole data. Here the data is small, so that's why we can easily like go on to one to another graph. But where the data is very large data, so how can we see that? So we should see always the diagonal one, which all variables are important for the data modeling. So here we see that three classes are not very well differentiated from each other. Here also they are overlapping. These two variables are, see them correctly, these two uh, variables are of more important, because uh, here the three classes are differentiating each other. This is highly differentiated class, these are okay differentiated classes, and this is also, they are differentiated from each other, so we can differentiate the classes here. So these two variables are of more important for the model building. Now we will see the box plot. Box plot is for looking at the outliers. So here most of the data is clean. Only the sepal width has some outlier, but I'll leave it like that only because decision tree classifier is a algorithm which is not very sensitive to the outlier, so it can handle the outlier. So I will leave it like that only. Now we will extracting the target column into separate vectors for training set and test set. Now this species column we will draw from the independent variable, and we will pop in the dependent variable, and now we will check it also whether it is dropped from the independent variable or not. So we can see that species column has dropped from the independent uh, variables. And now we will split the data into text and train, and there is 80-20 ratio, and random state is just for the we are like this is a seed value. This will give you the same result when you run the model again and again. This is something like the seed value, random state. You can give any random state value. This is up to you. So now this is again we are checking the dimensions of the training and test set, and this is very important. This should be matching. We have the value error sometimes, so value error is just because that these dimensions are not matching. These dimensions should match. So checking of the training and test data shape is very important. Now let us define the decision tree. Initializing the decision tree, and I am storing it in a dt underscore model, and criterion is Gini. Now we are fitting the model extrain and train labels, and now we have seen in the pair plot also the important variables, and now we can see the like up to which level they are important in terms of numbers also we can see. So now we are building a data frame, and we are giving the name of the column, the importance, and these are the features of the column. So now here from here also we can see that petal length and the petal width are the important variable for the model building. And now we will see the Y prediction, and let us visualize the decision tree now. This is for visualizing the decision tree. We will from sklearn import tree for visualization sake. And here we are visualizing the tree itself. I am not giving the hyperparameter to the decision tree like sample split, number of nodes and itself. We are simply visualizing the decision tree here. So this is our decision tree look like. And now we are y train predict is equal to dt underscore model dot predict. X train we are predicting the model, and now we are checking again the shape of the y train prediction and the y test predictions. And now we are getting the predicted class also. And now we can see the probabilities also in terms of number. And this is the data frame, and this is the probability data frame actually. And we can evaluate the model now. For the we are seeing the confusion matrix for the training data, and for this we know that from sklearn dot matrices import classification report confusion matrix. And this is the confusion matrix. These are the correctly predicted numbers diagonally. And this is our train data accuracy. Train data accuracy is one, it is very good accuracy. And this is the classification report. And here also we can see that accuracy is 1 for almost for all the classes. It is 1, so it is very good model in fact. And confusion matrix for the test data, because we have trained the data and very successfully we have trained it. And now we'll see for the test data. And this is the confusion matrix, and this is again diagonally the correctly predicted one numbers classes. And now for the train data accuracy, this is also very good, 0.966, 0.97 almost. So we can say that this is very good model in fact. And the precision and the recall also for the classes, for the first class also, second one also 1 and 0.92, and this is for the third class also 0.86 and 1. So this is in fact it's a very good model, and accuracy itself is also 0.97. So it's a very good model. And so that's how we have completed our decision tree. So conclusion, our decision tree is now ready to feed any new data in itself. Thank you so much.